The number you see on your screen, $54 million, that is the amount that is lost to phishing every single year. Nobody's safe from phishing. Even the tech giants such as Facebook and Google have had phishing attacks where they have lost up to $100 million. Hi, I'm Aman Sajjan Ansari, here with my teammates Jay and Paul to provide you a solution from this problem. But before you provide a solution, we have to understand what the problem is and how does machine identify that sort of problem. Machine identifies what is phishing, what is not, based on the pattern inside of the data. These patterns can be as simple as capitalization or a lot of exclamation marks, a lot of promotion rewards, a lot of URL links. Anything can be phishing, anything that is outside of what you actually do, what your actual work is. Most of the machine learning models right now in the market are based on the external data set. They build the model around that external data set, they get a really good performance, and then they classify it as phishing or not. We also did that initially, but we found out there was something missing, something that was just not clicking before we added the portion of internal data. The portion of internal data created a custom fit and boosted our accuracy by 6%. It is very important to understand that you have to get the correct data set. If you do not get the correct data set, your accuracy could go down really badly. Also, while adding the internal data set, we have to understand we reach a point of diminishing returns, where it is the more human capital that you invest on labeling the internal data, the results don't really go that high. So while designing our system, Fish, we have taken into consideration whenever Fish puts any mail as non-phishing and phishing, it also uses that, adds that to its internal data source. Why is internal data source so important? Internal data source identifies internal patterns. So for example, you're working in marketing, you get a lot of mails with URLs, or you're in finance, you'll get a lot of mails with dollar numbers. Usually out of the box, phishing identifying system will put them into phishing, but our system won't, because it understands that your jobs requires you to get those sort of mails. I will hand it over to Paul, who will take over you the model Fish and how does it work and why is it the best thing in the market right out there.
Thank you, Aman. Hello, I'm Paul. Let me introduce our state-of-the-art system, Fish, a user-friendly, interactive, and self-learning AI system. Fish has high accuracy model that can filter most of the phishing email, and Fish will identify latest phishing terms and keep the model up to date. Fish also provides monthly report to educate the user recent phishing technique and trend. So let's take a look at how Fish works. Fish is a web browser extension. Whenever you are checking your email, you will scan the subject and the email body, then provide the user probability of risk. In our default setting, we set 30% of low risk, 30 to 60 as neutral, and above 60 as high risk. We are more cautious about the high risk because identify phishing email as non-phishing is more costly than identify non-phishing email as phishing. But we also allow users to set their own threshold. Next, Jay will elaborate the risk analysis.
Thanks, Paul. Along with our methodology and commercialization, it is also critical to understand and try to avoid risks based on misclassification. In the confusion matrix on the top, 60 false positive misclassification can incur opportunity cost if important emails are filtered out as phishing emails. And the 90 false negative misclassification, which is the type that we want to avoid the most, can expose businesses or individuals to the various risks, which can cause serious financial and economic losses. Assuming that each phishing email has an economic loss of about $224, this model can bring about a potential loss about $20,000 compared to the average cost of $14.8 million in the US. To reduce this loss, we can lower the threshold of the model. However, false positive will increase in turn, so the threshold can be adjusted depending on how much the company considers a loss on false positive. In conclusion, these are the main things that we would like to highlight. We initially created a model using external data. Then to build a more sophisticated model, we incorporated more samples with the unique properties of phishing emails from the internal data set by performing word cloud and pattern identification analysis. Then we performed the strategic data selection to identify a point where we can generate the highest accuracy rate with using the least amount of the original data. Finally, through running an ensemble model, we have achieved a high accuracy rate of 98.5%. And based on our methodology and algorithm, we devised a commercialized product to help the company keep their employees safe and secure. This is the end of our presentation. Thank you for your time.